Hi everyone, my name is Jerry Bartles and I am a Technical Marketing Manager here at Autodesk. I'd like to welcome you to today's presentation where I'll be providing a technology review of the Autodesk Roadway Design for InfraWorks 360. During this brief demonstration, we will focus on several key aspects of the planning and preliminary design process used on road and highway projects. These include the ability to quickly create and explore preliminary roadway designs. Essentially, we would like to create more than just a napkin sketch. In other words, as we lay out our roadway and intersection geometry, it needs to be rules-based such that what we create is a realistic solution. We will also look at how we can optimize our project performance. We will do this through several different lenses. First, throughout the process, we will evaluate our project in the full context of its existing surroundings. Next, along the way, we will explore several tools that will assist us in estimating construction costs, as well as performing site analysis to help address areas of potential safety concerns. Finally, we will explore how we can share our results with others. This will include internal folks like the design team and sub-consultants, as well as external folks like the project owner, recommending body, and the general public. Now, the way we will focus on these key areas will be through a brief demonstration followed by a summary. We will also leave some time at the end for Q&A. My goals for today's session are easy. First, I want to give you some exposure to the roadway design for InfraWorks 360 solution, as well as a review of a subset of its capabilities. I say subset because it would take much longer than our meeting today to review all of its functionality. Instead, we will concentrate on the primary features and their related business benefit. In other words, how specifically does roadway design for InfraWorks 360 improve the preliminary road design process? So with that, let's go ahead and get started. We begin our demonstration with the following scenario. Our objective is to explore some alternatives where we can connect the community on the west with the community on the east. The catalyst behind the project is to reduce overall traffic congestion. Currently, there are minimal river crossings available. As a result, during peak traffic hours, the existing bridges on the north and the south cannot accommodate the required traffic flow. In preparing these alternatives, ideally we would like to find a route where we can connect this main road here on the west side to this main road here on the east side. Knowing this, as my initial proposal, I'm going to explore connecting from the end of this existing dead-end street along the existing roadway here and then into the open space. Now, to reach the open space, I will need to cross another main road at this point. From here, I will run my new road along the natural break in the property over to the riverbank. We will then cross the river and meet up with the existing road on the other side. Now let's pause for a minute and think about how long would this process take you today. Essentially, coming up with a concept, determining if it's feasible, as well as creating a deliverable to explain the design intent of your proposal. And as you think about that, let me show you how we can accomplish this objective using roadway design for InfraWorks 360 Pro. Now at first glance, it looks as though we're working with just a simple aerial photo. We are not. Instead, we are working with a 3D model that was created from freely available elevation data and aerial photography from the USGS website. Using this model, we can easily position ourselves at any point in space and immediately be able to visualize the existing conditions. We can see what challenges we might face with respect to vegetation, existing structures, as well as any changes in terrain. Understanding this, let's switch back to a top view and begin creating our proposed roadway. We will start the process by first creating a proposal. A proposal will allow us to capture the model in its current state and then record all of the changes from this point forward. In other words, we will use this new proposal to create our new roadway, and then when finished, we can easily restore the model back to this point. From there, we can create additional proposals and explore other potential routes. We will call this proposal Road Design 1. Our next step will be to begin our preliminary road layout. This is a very straightforward and easy process. We simply click on the persona-based roadway tools, choose our desired road type, and select the style. From there, we click the points to define our roadway. Notice as we do this, we have the option to enter a design speed. This design speed will determine the appropriate rules-based information during our layout. For example, notice as we change direction, a horizontal curve is automatically added. This curve is consistent with a 30-mile-an-hour design speed. We will go ahead and continue to pick points until we've crossed the river and tied back into the existing road on the east. Once finished, Roadway Design for InfraWorks 360 generates a completely modeled 3D roadway. Let's get a little closer and take a look. As we zoom in, we can see intelligent grips have been added to key points within our geometry. Clicking on these grips allows us to dynamically update our design in real time. For example, we can update the horizontal curve radius, move the PI location, or both. After any change, the model is automatically updated, providing us immediate feedback. Using this functionality, we can easily make adjustments to any portion of our original layout. For example, setting the size of this horizontal curve to 1,000 feet. As we move further to the west, several things become obvious. First, not only did our rules-based tools assist us with the horizontal layout, but also with the vertical. We can see that the change in grade from one PVI to the other created an overpass situation with the existing road. This happened automatically because before we got started, I created a quick roadway to represent the existing road in this area, so we could see the intelligence that exists when two modeled roads cross. If the elevation is such that one is higher than the other, an overpass is automatically created. If their elevations are instead similar, an at-grade crossing is automatically generated. Because an overpass is unnecessary in our design, let's adjust the vertical to create an at-grade crossing. We can quickly do this by displaying the profile view for our roadway and making our changes. As we review the profile, we can see the effects of the rules-based tools that were used as we picked the points for our roadway. In other words, PVIs, slopes, and vertical curves were all created consistent with a 30-mile-an-hour roadway design. The total length of this road is just over 2 miles, and you may be wondering if Roadway Design for InfraWorks 360 can optimize the overall layout for us. The answer to that question is yes. Included in Roadway Design is a cloud-based profile optimization tool. Using this tool, in conjunction with some cloud credits, we can leverage the virtually infinite power of the cloud to determine the best solution. We can begin the optimization process by clicking on the Profile Optimization tool, and after 30 minutes or so, a solution is delivered directly back to our model. For the sake of time, we will not perform the automatic optimization today, but I will show you an example of the automatically generated report that would be returned with the completed roadway geometry. The first page of the report contains a graph showing the optimized solution as well as some construction cost information. This information was determined using user-definable earthwork and construction unit pricing. The next several sheets show detailed road assembly and earthwork information to support the overall cost estimate. The report even contains a chart showing the proposed hauling scheme. The report concludes with cut and fill information at key points in the design, as well as a listing of every PVI station, elevation, and curve length. In short, by leveraging the cloud, we can have an optimized roadway design complete with supporting documentation. Once again, for our concept, we will continue to make our own adjustments. We'll start by adding a new PVI at the location of the existing roadway. Notice as we make the change, we see the model view update in real time. Our overpass has now automatically changed into an at-grade crossing, and we can continue to refine the profile such that it drains away from the intersection. We will accomplish this by adding another PVI and setting the station and elevation to meet our needs. Once again, we can see our changes update automatically and in context with the existing surroundings. As I make my final decision on placement, such that I maintain a 1.75% slope from the existing roadway, I'd like to take a closer look at the vertical curve that has been automatically applied. Just like what we did using the horizontal grips, we can update the vertical geometry exactly the same way. In other words, not only can I adjust the station and elevation of the PVI, I can also easily change the size of the vertical curve to meet my needs. Next, let's shift gears and look at the impact of both the horizontal and vertical design when it comes to road grading. We will begin by positioning ourselves in space such that I can see how our proposed road matches back into the existing ground. We can see we have some fill here closest to us and a fair amount of cut as we move up the hill. If we would like to alter the grading, we need only make a quick change on the road's asset card. Initially, our grading is set to a fixed width of 33 feet. But by updating this value to 50, we can immediately see the impact of the change. If we are concerned that matching in at 50 feet may disturb too much of the existing area, we can set a fixed cut and fill slope to match back in sooner if possible. With a strategy in place to adjust our horizontal and vertical design, as well as our road grading, let's perform a quick site distance analysis to see if our preliminary design has any areas that are prone to safety concerns. This is very easy to do. After clicking the Analysis tool, we can choose between a stopping site distance or passing site distance analysis and confirm our direction of travel. Note, you also see an option to choose lane. Now our road design has only one lane in each direction, but if it had multiple lanes, Roadway Design for InfraWorks 360 is capable of performing the analysis on each individual lane. With our analysis completed, let's take a look at our results. We'll start up here at the top of the hill and then position ourselves looking back towards the intersection. As we do this, we can see the forward lane of our roadway has been colored to represent different site conditions. The light blue areas indicate no issues. The yellow areas represent some form of site failure. The dark areas represent a potential accident zone. And any red areas represent a complete site obstruction. If we would like to drill down deeper into the analysis, we can place site pins to see exactly the extents of the obstruction. Using these site pins, in conjunction with displaying the site envelope, shows us areas of our model that will require some additional attention. For example, in this area, to eliminate the issue, we could change the road elevation, alter the grading, increase the radius, and more. Because we are working with a dynamic model, we have the power to experiment with multiple what-if scenarios to achieve the best possible solution. Let's move further down the road and check out another example. In this instance, the road is straight, but there still seems to be a passing site issue. After closer inspection, we can see that the likely cause of the problem is a grade change at the PVI. To resolve the issue, let's alter the length of the vertical curve and see if it makes a difference. By selecting the appropriate grip, I'll set the curve length to 1,000 feet. I'll then perform another analysis and verify the results. When finished, we can see that the forward lane is now clear and free from any passing site distance issues. Now please note, when it comes to site analysis, we are not limited to just the roadways. We can also perform site analysis on intersections as well. Let's reposition ourselves to view the intersection created where our proposed roadway crosses over the existing road. As we maneuver into position, we see a tree at the southeast corner of the intersection. Now before we started, in addition to me creating the existing roadway, I also added this tree, and you'll see why in a few minutes. But first, let's take a look at the intersection geometry. By clicking on the intersection, an asset card is displayed with a rules-based tool to control the intersection radius. In other words, the default radius has been set up to accommodate passenger cars. But what if my roadway design will require truck traffic? How would I accurately represent that in my model? Well, using this tool, it's very easy. We simply select the appropriate vehicle type and the geometry updates automatically. Next, let's take our intersection geometry layout one step further. The primary road through the intersection will likely remain the existing north-south road. To facilitate a better flow of traffic, let's explore adding some turn lanes. To do this, we simply click on the desired lane and then drag to create our widening. For our first pass, we will see how a 40-foot distance looks. Remember, we can start with rough numbers and then use the asset card later to make them more exact once we make our final decision. You know what? I like the way that my intersection looks, but I think I'm going to go ahead and update my values to 45 feet for both the south and the north side of my intersection. With our intersection layout complete, let's perform some site distance analysis. We'll begin by positioning ourselves so we are looking down on the intersection, and then choosing the analysis tool. When working with intersections, I can choose my direction of travel, as well as which road I am interested in checking. Notice as I hover over a road, I get immediate visual feedback. Once I choose an approach, I can analyze my intersection using stop or yield control. I can then choose my maneuver. In this case, I will perform my analysis for a left-hand turn. The results of my analysis show site envelopes to indicate the area that must be clear. Because we are working with an aerial photo, we can compare these areas against what we see in the aerial imagery. In our case, everything looks good. Let's switch our analysis to the opposite direction. Using a stop control with a left-hand turn, our sight distance lines are also in good shape. Because this is a more rural area, let's see what the impact would be by switching to yield control. Our sight envelopes are now much larger, but when compared to the aerial photo, we should still be okay. However, performing the analysis on the other side produces a very different result. Using yield control, we can see that the tree does pose a safety issue. And that's exactly why I added it to the model, to show that if modeled, Roadway Design for InfraWorks 360 will factor all of your modeled geometry into the analysis. Now that we have a strategy for dealing with safety issues related to sight distance analysis, let's continue to work our way further east. As we do, keep in mind that we can continue to make edits and have our model respond accordingly. For example, I can still edit the horizontal geometry of my roadway and not lose any of the values I used laying out my intersection. As an example, I will adjust the location of this PI, and my road geometry as well as my intersection will automatically update. Alright, let's continue on to the east and quickly model our bridge crossing. Now when it comes to the bridge, we will model it as 4 lanes rather than only 2. In the future, this will provide us some cost savings in that when our proposed road reaches capacity, we can widen the road without also having to invest in a bridge widening project. Widening the bridge is easy. We simply click on the roadway, use the asset card to specify which lane will be widened, and then create a new zone. From there, we will click where it should start, and then where it should end. Using the existing surroundings as my guide, my bridge will be approximately 450 feet and run from station 8500 to 8950. Keep in mind that as we do this, these grips too are also dynamic and can be changed at any time. With our zone established, we go back to the asset card, assign the number of lanes, and our model is automatically updated. Because our bridge will be symmetrical, we will complete our bridge widening by switching to the opposite lane and then creating a zone using the same parameters as the first. When complete, we have a widening, but it doesn't really look like a bridge yet. In other words, our entire road is currently defined using the initial road style from when we originally laid it out. To make this area look more like a bridge, we will define a new style zone and apply the bridge style. Notice the process used to determine the start and end of the zone is the same as what we did earlier. When working with Roadway Design for InfraWorks 360, you will find a very consistent look and feel to the user interface. With our style applied, we will position ourselves in space to get a better look at our bridge. We can quickly see that bridge piers have automatically been placed in the area where we cross the river. With our bridge complete, we have accomplished a lot when it comes to our preliminary design. At this point, let's create a quick animation so we can truly experience our project as it's currently defined. Now normally, when it comes to creating an animation, we don't think about the process as being quick. Instead, we start thinking about renderings that run all night and needing special hardware, software, or a visualization specialist to set it up. Fortunately for us, Roadway Design for InfraWorks 360 is different. We can create a complete animation in real time with only a couple of clicks. We begin by creating a storyboard and then using our proposed roadway as the camera path. That's it. After a short amount of processing, we can immediately view our animation. Now because our road is 2 miles long, I'm going to accelerate the playback so we can quickly see from one end to the other. And when we click play, our animation begins. As we experience our proposed roadway, I'd like you to think about a couple of things. First, what do you typically use to convey the design intent of your projects to, say, a recommending body? Do you mount construction drawings to foam core boards before heading out to the meeting? Maybe you don't use construction drawings at all, but instead create marker renderings or color exhibits. How long do those take to create, and how easy are they to update? And in either case, does everyone immediately understand what you are proposing? In a project like this, I'm sure you can imagine that multiple property owners will be impacted. Additional right-of-way will be required, and lots of folks are going to have questions as to why this route and will it actually work. Using Roadway Design for InfraWorks 360 to create an animation like this provides us the tools to address any of these questions. Additionally, animations like these can be exported such that they can be used on a website. Imagine how beneficial it would be for the public to experience the multiple alternatives prior to the public hearing. Finally, Roadway Design's dynamic updates in real time also gives you the option to leverage your model right there at the meeting when responding to questions. At this point, I am pretty pleased with where my roadway project stands and would next like to get a rough estimate as to the earthwork required for the improvements. Remember, there was a fair amount of cut on the west side, and I am interested to see if I am anywhere close to balancing. After making this determination, if necessary, I can further refine my roadway concept. To determine this value, I will have the system calculate some rough terrain statistics. Essentially, this tool was designed to calculate the changes to the existing terrain as a result of my improvements. To perform this calculation is simple. I need only pick points to define the limits of the area I'm interested in computing. When finished, the results are displayed, and I can see that I have substantially more cut than I do fill. To help offset this, I can go back and further refine my preliminary design to help address the difference. When I am completely satisfied with this conceptual layout, I can restore my project to its original state and then create a second proposal to explore a different route. I'm sure you can imagine that there are numerous possible routes that can be considered. I can also easily return to this proposal at any time to make any further refinements. Well, now we have our answer. In roughly 15 minutes, we were able to explore a proposed solution for this project, and it is far more detailed than a line drawing on an aerial photo. Instead, it is a dynamic 3D model we can use to estimate the project's feasibility. We can perform various forms of analysis to uncover potential safety issues, as well as produce an animation that we can leverage to quickly convey our design intent to any of the stakeholders. And if our concept is approved, we're ready to take our preliminary layout to Civil 3D, where we can perform more detailed design. To summarize, what is Autodesk Roadway Design for InfraWorks 360? Essentially, it is a software solution that helps transportation professionals more effectively explore preliminary roadway design options in context, optimize project performance, and share the results. During our demonstration, we used it to streamline the layout of our roadway geometry. Once created, we could leverage intuitive grips or other tools to update the geometry and see the results in real time. We saw that leveraging the infinite power of the cloud to optimize our roadway profile was also an option. And throughout the entire process, we were able to perform various forms of analysis, even on our intersections, to assist us in computing volumes as well as uncover potential safety issues. As for the business benefit, Roadway Design for InfraWorks 360 is easy to use, very intuitive, and extremely powerful. Its numerous features will enable you to speed the preliminary road design process, as well as more quickly evaluate numerous design alternatives, such that you can present your client the best solution possible.